Right, let's get back to our actual topic. I would like to present the company Vorpco GmbH to you, and I looked at the solution that they will present to you, and I'm very excited for the details on that solution, and I'm sure our speaker will give an excellent explanation. This is about the manufacturing process and a revolution within that process. I'm looking forward to Vincent Vorpco. He's the founder and CEO of Vorpco. If you have any question, please ask them on Slido. I would like to pass the floor now to you, Vincent.
Sven,
thank you very much for the kind introduction. First of all, to all of you, all of my guests who have followed the invitation, a very warm welcome. Thank you for being here and for supporting us. We are new to the market, which is why we're especially delighted to present our new technology to everybody who is here. We will do our product launch here and now today. Who am I and what are we doing? For 15 years, so that's my entire career. I've been active in the supplying industry for machine tool manufacturers. We've worked together with the biggest players of the industry, and we have rendered machines safer. That is why we are especially proud of presenting something new today, which we have never done before. Let's look at the roadmap for today. We have three main focus points. That's first of all who we are, what have we done in the past, of course, and then how can we get more transparency and more monitoring into the machine, and then at the end we want to look at how can we have an entirely different approach to this thing, and we'll have a little surprise for you. Now let's look back to our history. So far we have done a lot of hardware components for machines, hardware components directly inside the machine. We have protected machines from chips or from oils, residual oils, and what we've experienced very often is that we were dealing with a glass wall that wasn't transparent, really. There was a lot of coolant around oils, liquids that were preventing us from looking through the glass, and that is where we came up with our new focus. We left the protection components world, so to say, and thought about what can we do in order to get a better look inside the machine. So that is the outer perspective. Now I'd like to introduce a little experiment to you. This might become a little wild, but let's go in together. For 2 seconds I will close my eyes and then see what happens. Weird. We're in a major space. There's so many machine tools around here and we don't see anything. That is a very annoying feeling. So you'd have a spindle with 25 circulations per minute and you don't see anything. This is what you see. 25,000 rotations per second, and you don't see anything. There's absolutely no control. You simply do not know what is happening inside the machine. That means the coolant and the chips in sum lead to less control over our actual manufacturing process. And that means that we're dealing with a major problem. Right, what we believe is that CNC workstations should remain high-value workstations. We believe that the operators on machine should be able to look inside the machine with their own eyes. They should independent of the AI solutions that already exist. How can we solve this problem? How can we make the operator have a look inside the machine? Right, this is one solution. That is a rotating spin window. This is nothing new. These windows have been existing since the 40s. We have seen solutions where trains and planes in the military area would have these spin windows in the front. These things do exist, but the question is how can we integrate that into the process, into the machine tool, and how can we be intelligent in this process? Resource saving, how can we save energy? All of those things that are very important these days, and these things do exist. I'll show this to you. So water hits the glass, centrifugal forces take it away. It's a very simple process. It is then transparent. It spins. We know that. We know that from school. There's a merry-go-round, and the water drops are being carried away. So what's new? And this is it. What's very decisive here is that we looked at how we can boost this product, and that was naturally very difficult. This is very simple. We can use an electronic motor, an electronic engine, revolutionary motor on the inside, which is not visible. The motor actually hides parts of the glass window. And then we equip this with a rotating motor without magnets. I'm not sure how deep you are in electronic science. There's an electromagnetic coil with a constant magnet, and that is how things get in motion. This applies to cars, applies to cranes, but we're in a machine tool here. This glass window is used a lot. There's a lot of pressure on this glass, which is why it needs to be replaced very often. It is a very important technical part, which is why replacing it is very costly. And it leads to downtime. So we use resources for these magnets and then we waste them. That's usually the case. So for us, what was very central to developing this product is how to improve this process so that we don't waste anything, and that it doesn't come with downtime. So there were positive effects. So I'm jumping to point number 5. This glass is now ultra slim. This comes with problems, but also with benefits. Now, usually we have highly integrated, highly performative glasses with doors, where the tools are being changed quickly, so every millimeter actually counts, and that is a problem that we solved. This is the slimmest window on the market, 22 millimeters in profile, and it fits every interim space for every machine tool. And now what comes in now, smart solution. This is simply rotating. What is so smart about it? Well, this rotary motor comes with another benefit. Because there are no electronic magnets on the window, there's never the question of whether it has to turn and how fast. So this is where our idea came in of using that motor. If the motor detects water drops on the window, we can adapt the speed of the rotary magnet. We can pulse the speed, go up and down with the speed, and that turned out to be a major game changer. This improved the performance, the energy efficiency, and it rendered our entire system smarter. Now we're back here, and now the question is, how did we solve the problem? That's right, we did solve it. Now let's go back a couple of years. There was the pandemic, or even more, the globalization. Now imagine the place of the machine tool to be a different one than the one where the expert is. So you have a machine tool, and you want to know whether it is still working. So we need something to monitor our machines remotely. How can we do that? Yes, we can install a camera inside the machine. That's a simple solution. But remember, we have the coolant, we have the chips in the machine, and we don't see anything. So we're back to square one. We could have a very smart solution, an efficient rotating plate inside the machine, but with pumping pressured air into the camera. I'm still confronted with the problem that I don't see anything. So we tried coming up with a simpler way. I think all of our mobile phones now have 3 cameras inside. So why is installing these cameras so complicated and so pricey? And we discovered an incredible technology which I would like to present to you now. What you see here is that the lens is cleaning itself. So what is happening here? Don't worry, we do have enough time. The lens was dry initially, so when the sensor was hit with liquid, nothing changed, and then when the lens detected the drops, the lens activated the self-cleaning process. So there was a type of fog, and so you'd think, is there something hot? Is that water vapor? No, that would not work, because then the oil would stay on the window, on the glass. What you saw here, I explained to my daughter as follows: if you have a drum and I put some coins on top, they are the symbols for our cuttings that we have. So I use the drum and I make the surface move. So what happens? The coins fly away, fly off. The problem with my daughter is that these coins were moving uncontrolled. That wasn't a process that we could sell to an actual client. So what's behind this technology is a chip. We came up with a control that comes up with these ultra-high waves in a way that detects whether or not there is actually a chip or a water drop and how much of it there is. And then the sensor detects micro movements and adapts the waves of the movement of the window. So there would be specific patterns of specific frequency, and come up with the ideal frequencies and patterns to transport away the residual water or oil or coolant. And it is actually incredible. We showed this to our clients yesterday at the booth. Clients are astonished. They think this is actually magic. So there's so much high-tech in one lens. So what is actually the special thing here? This is actually making things cheaper. It is rendering things available for more clients. And this is where we really come in. We have a major cost advantage. It is a tiny solid-state camera with the smart technology inside. So enough on that. We talked about the lens. So what's this now? Right, if we have produced a picture, an image, we need to use that for something. What we did here is a first draft. We came up with a technology that retrieves the signal. We're not talking about a large amount of data, a FACRA cable that is used for any car, for example, for data transmission. So we made the data better, so they can be handled better, and we inserted this pulse shield mechanism. We also inserted some AI. We can detect persons now. That is the classical thing that we did. We presented that yesterday at our booth. People were astonished. But that is not what we're dealing with here. There are software developers out there who are a lot better than we are. We make sure that our clients get a picture from the machine, and what they do with that picture or that image, that's their thing, but what we're doing here is providing these images. Or, of course, fully integrated systems. You're at the machine, you're an operator of the machine, and the question is, how can you transfer this image to the machine through an interface, an IP address transmittal? You then have your image in the machine, and there's a third eye looking at the image, additionally to the rotating viewing window. What is exciting here is that we did talk about manual manufacturing and the remote monitoring here. So we've come a far way, but there's still a little problem. You have a major machine tool. It is operating at night. What happens if there's a problem at night and nobody is around and there's a major downtime? This enables us to remotely monitor and control our machine through images, and these images can then be analyzed by AI. No human has to stay up at night to monitor these pictures. Now, I gave you a lot of information, but I have three key takeaways that I would like to to present to you now. We as Vorpco, we are a young business. I do have some more experience in the industry, but we're still at the beginning, and we would like to dive into a dialogue with you and to see what we can do together. And I think we have come quite far, but there's still a lot to do. And we only started in April. We started to set up the technology, and we're extremely excited. We have had so many beautiful talks and dialogues, and we really think that we can come a long way. So make sure that you render your process visible, look at what is actually happening inside of your machines. That is what you can do with our help, and I think there are little and big efficiency gains. And what I also want you to take away is that we give you 24/7 machine insights. I intentionally left some time so that we can dive into this dialogue. I can see that there are experts around. Thank you for following the invitation. And that is why I would like to ask you, my audience, whether or not you were already inspired by my presentation or whether you have technological questions. But first, a big round of applause. Thank you for the presentation. Thank you for the exciting solution. I do have a couple of questions, of course. What I'm interested in, because we talked about the use of AI, you mentioned that we have the camera picture, we look into the machine, it is a high-resolution camera. Wouldn't it be great to do quality assurance? Because I can see the part while it is being manufactured, and I can also see whether something is going wrong along that process. Wouldn't that be a first step? Yes, very exciting. I personally didn't think about that, but yesterday we came to contact with a control unit manufacturer. They do surface monitoring processes, and I think there was that major effect of people thinking, how do you do that? They thought it was magic with the camera. What's important here is that within the machine, we get insight of what is actually happening. So your clients, if I understood things right, machine tool manufacturers or machine manufacturers who do that, is this already being used in some machines, or are you still looking for actual clients? What's the situation? No, right. These cameras are in a test machine in our company still, but this is an important point. There is currently no OEM who is, or real client who is using our camera, and we're looking for exactly that. And early on in the manufacturing process, they of course need to get in touch with you. So would you say, I'm not sure how to put this right, what is the difference to traditional solutions on the market? Right, I would say when it comes to the result, the difference is not that big. There are options to take a look inside the machine. There are other companies who do that, but the difference is in the detail. We can provide a major cost savings by 70% is what we can provide. I saw a client yesterday, and they stopped actually maintaining their windows, exchanging these windows, these glasses, because it's simply too expensive. I do have a question from the audience. First, it is a rather long question. How do you make sure, how does the camera make sure that there's an EMV security of the of the AI component? You probably know that I don't know how to answer that. Well, I think that's difficult. Let's start with less technical approach. This technology is not new to the world. This has existed for cars. There are sensors, LiDAR sensors in the front of cars, and lenses such as ours are, they are equipped with these lenses. So simple answer to the question, I don't know, but we do know from other applications and from our tests that there have not been problems so far. Another question, how often does the camera actually pulse on demand? or generally? I forgot that, sorry. The lens comes in different modi. The current function comes with 4 modi. First, there's a manual mode, a full power mode. The second is an automatic function with auto detection, and every few seconds a little test is being done, a little image is being retrieved, and then we have an automatic mode with middle power mode and a middle power standard mode. So the auto detection is already built in. All right, there's an exciting question here. What is the cost of the 2 products and when will they enter the market? I hope that this is a client with an actual interest. Well, I can only answer this in a vague way. The camera unit comes at €399, and the control unit, this is rather hard to answer because there's the question of whether an AI component will be built in or not. That's €800 to €2,000. This depends on the software behind, and for the window, that's €1,400, €1,500 for a new for the new model. But we can exchange the windows in older machines for less than €100. And this leads us to our next question. So these windows need to be replaced and exchanged often. So does the use time through your system pay off? Yes or no? Well, I'm not sure. Well, it is a usual type of glass that is turning in that lens. Well, for cast machines, there are very strong and hard cuttings. So I think a year is a rough time that it can work and that it needs to be replaced. Right, thank you very much. Strong solutions, I'm astonished. Thank you very much. Thank you, Vincent. Keep going, and I hope that you will find some clients here at the EMO. A big round of applause for Vincent Vorpco. Thank you very much. Thank you.